Good morning, children. Welcome back to mathematics class. Hope you all are fine and safe and staying very well at your homes. Let us start today's lecture. This is class 10th, subject mathematics, chapter number 2, polynomials, lecture number 2. So children, in today's lecture, the topics which I am going to cover, they are number 1, division algorithm. Number 2, division algorithm of polynomial. This is Px. Actually, it is the representation of polynomial in X. Fine. And the third topic is how to obtain other two zeros when a biquadratic polynomial and its two zeros are given. Clear, children? Now the very first topic is division algorithm. What do you mean by division algorithm? Division algorithm is basically the way to verify after division. Children, you learnt it in your junior classes also. After division, after getting to know about the quotient and the remainder, you used to apply this division algorithm. What is the formula of division algorithm? That is, dividend is equal to divisor into quotient plus remainder. But here, as we are dealing with polynomials, so the formation of this division algorithm for polynomial will become like this. That is, Px is equal to Gx into Qx plus Rx. Why I have written here x? Because you know that here we are going to deal with the polynomial which is in variable x. Correct? So what is Px here? Px is dividend, Gx is divisor, Qx is quotient and Rx is remainder. Suppose if at place of Px, Gx, Qx and Rx I am going to write down these names. So what would it become? It would actually become the division algorithm only. Look, this is dividend is equal to Gx is divisor. So divisor into Qx, that is quotient plus remainder. Clear, children? To understand the concept of division algorithm, children, I am going to take example number 6 from your NCERT book. This is divide 2x square plus 3x plus 1 by x plus 2. This is a quadratic polynomial because the highest power of the variable present in this polynomial is 2. And this is a linear polynomial because here the highest power is 1. So let Px is equal to 2x square plus 3x plus 1 and Gx is equal to x plus 2. Please be focused how to divide it. Here this is dividend, this is divisor. So by what value I should multiply complete divisor, that is Gx, so that I can get 2x square, the very first term, or even more than that also. I am going to multiply this Gx by 2x. Fine. So what I have got, children, when 2x is multiplied by x, I have got 2x square plus 2 2s are 4, that is 4x. In division, you know we have to subtract. So after subtraction, this 2x square and minus 2x square are going to be cancelled. So here what I have got, children, I have got minus x plus 1. Now by what value should I multiply x plus 2 so that I can get here minus x? So I am going to multiply it by minus 1. I have got minus x minus 2. Changing the sign, minus x and plus x both are going to be eliminated, cancelled. So here I have got remainder as Rx. Now children, as I told you that division algorithm is basically the way to verify. Now verification I am going to begin with using division algorithm. So what is the formula of division algorithm for polynomials? That is Px is equal to Gx into Qx plus Rx. Now children, we had Gx as x plus 2 into 2x minus 1, you had Qx plus remainder. Fine. So you have to multiply both of these expressions because we have to apply BOD mass. X will be multiplied by 2x, you will be getting 2x square. Then x by minus 1, you will be getting minus x plus 2 2s are 4, that is 4x. Plus 2 into minus 1 will give you minus 2 plus 3. After simplifying, we have got 2x square plus 3x because plus 4x minus x will give you plus 3x. And here minus 2 plus 3 will give you plus 1. Isn't it the complete division, that is Px? So through this we can verify after dividing. Clear, children? Now children, I am going to take one more question. This is from exercise 2.3 NCERT. Question number 1, second part. You have to divide this polynomial in x, that is x raised to the power 4 minus 3x square plus 4x plus 5 by gx, that is x square plus 1 minus x. Clear children? What you have to tell in this question, after dividing px by gx, you have to just tell what is qx and what is rx. Fine. One more thing I am going to add in it, that is you have to tell whether gx is a factor of px or not. Fine. So let us start division. When px and gx, always make sure before you start division algorithm, you have to make sure that both px as well as gx must be in descending order. So write px and gx in descending order. What do you mean by descending order? Descending means you have to start from greatest to smallest. Children, here you can see. How will we come to know whether it is written from greatest to smallest? Children, here you have to judge the powers of the variable which is present in this polynomial. See, this is highest power 4, then 2, then 1, and here x raised to the power 0. So means it is in descending order. Let us discuss about gx. Highest power is 2, then after it is written 1 only. Can I write 1 as 1 into x raised to the power 0? Means the power will be 0. Now here power is 1. So means this complete expression is not in descending order. So it must be written in descending order first. So after converting it into descending order, the expression will become x square minus x plus 1. Correct? Now children, we are going to start the division process. This is complete px. This is gx. Now I am going to multiply complete gx by x square so that I can get either one or more than one term which I can eliminate after changing the sign, after subtraction. Correct? So x square will be multiplied by x square. I have got x raised to the power 4. This is minus x cube, because x square into x will become minus x cube. It must be placed aside because in dividend, or I should say in px, there is no term having x cube. Fine. So now x square will be multiplied by 1. It would become plus x square. Changing the sign because we have to subtract. X raised to the power 4 and minus x raised to the power 4 are going to be cancelled. Clear children? Now you have to take this term first, that is plus x cube. Here it would become minus 4x square because minus 3 minus 1 will become minus 4 plus 4x plus 5. Clear children? Now by what value I have to multiply this complete gx so that I can get x cube? I have to multiply it by plus x. It would become x cube. Then x into minus x will become minus x square and then plus x. Correct? Now I am going to change the sign. Clear children? Here x cube and minus x cube both are going to be cancelled. Here I have got, after solving these both the terms, minus 3x square plus 3x plus 5. Correct children? Now I am going to multiply this complete gx by minus 3. So what will I get? Minus 3x square plus 3x minus 3. Correct? After changing the sign, because I have to subtract it, both the terms are going to be cancelled. So here I have got remainder as 8. Correct? This is Rx actually. You may be having a question children in your mind, why I am calling it Rx though x is not present. Children, x is present here though it is not visible to us. Can I write 8 as 8x into raised to the power 0? Yes, of course, it can be written. Clear children? Now children, after dividing, I have got qx is equal to x square plus x minus 3. And what is rx? That is 8. Here what can we say? Whether gx is a factor of px or not. Children, how do we come to know whether gx is a factor of px or not? For that, always keep one thing in your mind. If I say that gx is a factor of px, means gx will divide px exactly. But here we have got remainder as 8, which is not equal to 0. Suppose if here I was going to get remainder as 0, so definitely I could say that gx is a factor of px. But here we cannot say that gx is a factor of px because instead of 0 I have got here remainder as 8. Clear children? Okay, now let us switch to the next question. This is question number 3. This is the last type of today's lecture. What was there in this type? You will be having a biquadratic given. You know children, in biquadratic the highest power of the variable will be 4. So definitely biquadratic has 4 zeros. And you will be having 2 zeros given. Using those 2 zeros, you have to just find out the other 2 zeros. Fine. So what is the procedure? What is to be done in this case? The question is obtain all other zeros of px, that is 3x raised to the power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and minus of root 5 by 3. So what are the given zeros? Given zeros, so let us consider them. The very first zero as alpha and the another zero as beta. So let alpha is equal to root 5 by root 3. I can call this root now separately also for both of them. This is root 5 over root 3. And beta has minus of root 5 by 3. Correct? So what you have to do? You have to first of all find out a quadratic polynomial using both of these zeros. For that, children, I have explained you what is to be done. First of all, you have to calculate sum of the zeros. That is alpha plus beta. What is alpha? Root 5 by root 3 plus what is beta? Minus of root 5 by root 3. They both are same values with a different sign. Fine. So definitely they both are going to be cancelled. So what I have got as sum, that is 0. Now find out product of the zeros. That is alpha into beta. So it would be root 5 upon root 3 into minus of root 5 upon root 3. Fine. So what I have got, root 5 into root 5 will become 5 and root 3 into root 3 will become 3. So the product of the zeros will be minus 5 by 3. Now children, the required quadratic polynomial, what is the formula for that? That is x square minus sx plus p. What is s? This is nothing but alpha plus beta, means sum of the zeros. And what is product? That is alpha into beta. Fine. So x square minus sum we calculated as 0. So 0 into x plus product was minus 5 by 3. So 0 into x will become 0. What we have got? We have got x square minus 5 by 3 is equal to 0. Taking 3 as LCM. So what will I get? 3x square minus 5 equal to 0. While cross multiplying 3 by 0, it would become 0. So this is 3x square minus 5 is equal to 0. Children, basically this is that very quadratic polynomial which we have calculated using the given zeros of a biquadratic polynomial. Fine. So definitely this would become the factor of px. So here what I have written, here 3x square minus 5 is a factor of px. If it is a factor of complete biquadratic polynomial, that is px, means it must divide px exactly. Means the remainder must be 0. So now let us start the division process. This is 3x raised to the power 4 plus 6x cube minus 2x square minus 10x minus 5. You have to multiply it by 3x square minus 5. Now multiply this complete gx by x square. So what will I get? 3x raised to the power 4. Here I will get minus 5x square. Correct? In division I have to subtract. So it would become minus because there was plus written actually. This is minus and it has become plus. Both are going to be cancelled. This is 6x cube. Here plus 5 minus 2 will become plus 3x square. This is minus 10x minus 5. Correct, children? Now you have to multiply complete gx by 2x. When you multiply 2x by 3x square, you will be getting 6x cube. Plus, when you will multiply 2x by minus 5, you will be getting minus 10x. Fine. Changing the sign, both the expressions, both the terms are going to be cancelled. So we have got 3x square minus 5. Now multiply this 3x square minus 5 by plus 1. You will be getting 3x square minus 5 as it is. Changing the sign, they both are going to be cancelled again. So what is the remainder I have got? That is Rx is equal to 0. Clear, children? Now children, how to find the rest of the two zeros? We have got Qx as x square plus 2x plus 1. I am just going to equate it to 0. So this is nothing but a quadratic polynomial. You have to apply factorization method, to which we call splitting the middle term also. What is the sum? Sum is 2. And what is product? Product is 1. So you have to factorize it in such a way so that the sum of both the factors should be 2x and the product should be 1x square, or I can call it x square also. Fine. So this is x square plus x plus 1. Let us add them. This is 2x, which is sum. Let us multiply them. X into x will become x square. Now from first these two terms, you can take x as common. It would be x plus 1. From these two terms, you can take plus 1 as common. It would be x plus 1. Now this is x plus 1. Here also x plus 1 will be written once. And the rest factor will be, the second factor will be x plus 1 again. Fine. Equating, because the product of both the expression is 0. So you have to equate either 1 0 or another 0, or you can put both also 0. Because I have to calculate both the zeros, so I am going to put both the expressions equivalent to 0. So x plus 1 is equal to 0, and here also x plus 1 is equal to 0. So what I have got, children, x is equal to minus 1 here. Similarly, x is equal to minus 1. So thus, 4 zeros of the given biquadratic polynomial are root 5 by 3, minus of root 5 by 3, minus 1 and minus 1. Clear, children? Now understood, children? That was the most important type of this chapter, polynomial. Now you please switch to your mathematics homework. Your maths homework is, you have to do question number 1, first and third part. Second part, children, I have taken. Question number 2, you have to do 1 to 3 parts. In this question, you have to just tell whether gx is a factor of px or not. Fine, children? As well as you have to do question number 4 of exercise 2.3. These 3 questions belong to 2.3. Along with it, children, you have to do question number 4 of exercise 2.4, that is optional exercise. This question number 4 is based on the same type in which a biquadratic polynomial is divided by a quadratic polynomial, which was the last question of today's lecture. Fine, children? Along with classwork questions in your homework notebook. Clear? Any confusion related to it? Fine. Thank you and have a nice day.